Good day, everyone. Today, we're going to be measuring data for the probability and statistics course. All right. In today's lesson, we will review. Of course, I will teach you. We're going to analyze some data, and we're going to do our conclusion. So, look, in the statistics class, after each lesson that was completed, I will always make sure that I would post the video of the lesson that was taught. So therefore, if you get confused or you fall behind, you could always go to Google Classroom and get access to your information. And of course, we always start the news with Lester Hoyt. Always. It's always the news of the evening, the national news, not the local news, because I know you guys can watch the local news. All right, announcements. Um, in the class period, I told you guys that due to me having more than 10 people, I can't just automatically dismiss students, you know, or allow you guys to just check out. Because one of you guys do it, you all want to do it, which is not cool. So we ain't doing that. Um, like I told you guys before, you guys do have homework. If you have not done so already, make sure that you guys watch the presidential debate between Kamala Harris and Donald Trump. It was quite, entertaining. So you guys may want to do that because we will be talking about this, and that's something that I'm looking for in terms of a grade. So we're going to learn how to speak with a statistical etiquette. So when we do our statistics, we have to learn how to communicate in such a manner. Participation is all of what you speak. So in this course, the participation grade is key. Without that participation, you can't do it. I'm sorry. And just remember, all topics are up for discussion. Nothing is left unturned. Even the cringiest topics are open for discussion. Make sure you guys respect each other. Having arguments is okay. You're going to have an argument because you're going to feel strongly about things, and that's okay. All right. Last year, we had a good time with a good argument, and we learned how to do it in such an eloquent way. So, and that's what I'm trying to teach you to do. So, if there's something that you strongly against, and you have someone who disagree, take no offense to it. Just listen to the person, despite how cringy it may be. All right. So I know this. I know last class period we talked about labor force and self-hosted cancer, but this week, well, in addition to this lesson, I'm sorry, the lesson that I'm recording, we're going to talk about I were. I'm not really too interested about self-hosted cancer because I told you you guys should look into that at some point, and we could see. All right, let's review. Okay, we did not do our Kahoot, so I will post the Kahoot after I will post the Kahoot that we should have done so you could get practice. Because just like in the other math class, practice makes perfect. All right, remember the definition of mathematics. This definition is key, is king. Make sure you have it. I may require it for projects. Mathematics is the technique to understand, explain, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. This is the essential definition. In statistics, all of you called out that we definitely would be making a lot of inference, which is true. We haven't really counted yet. I know it's shocking, but we didn't really like count because the numbers was already given to us, so we didn't have to, you know, summarize or using the operations to get to those numbers. We measured, we classified. No, yeah, we did classify, but we did not order, we did not cipher, or we didn't really count just yet. And we also modeling patterns arising in the environment. That's the regression. But we haven't done it in class either, so we can mark that out. We haven't done the modeling patterns arising in the environment at the moment. But we did certify the mathematics as a technique to understand, explain reality, and manage it by measuring, classifying, and inferring so far. Remember, data is a number that tells a story. After we get through with doing the tools of statistics and all of that stuff, we're going to talk about data some more in terms of the various types, because there's buku types of data. All right, so data you will soon learn is not just a number, but this is what I taught you throughout math, and you're going to get a real taste in depth about data. All right, so don't forget, statistics is giving context to the data to inspire change. This is how we make our decision making process. This is how we make decisions. All right, like for example, it may be 100% chance for rain. That's going to, we're going to make a decision based on that percentage that, okay, well, I'm going to have to drive slow. I may have to take a different route, get into my house. I may have to make sure I wear a poncho and a big old umbrella. Don't forget, where data come from is very important because as we deal with the politics, you're going to be dealing with data that's going to be suspicious. You're like, can't verify that. I'm not going to use it. So it's very critical to pay attention to your source of the data. So I told you in the lesson we did in class about researching this question. Do cell phone cause cancer? What I wanted you to do is to identify the type of statistic, the type of study, and the parts of the measurements which you couldn't have done it because you don't know the type of measurements. So I want you to be only worried about the two. So you're not going to do the last one because I have yet to taught it. I have yet to taught the lesson. All right. So look, we're going to be writing statistical reports. So we have to learn how to write statistically. When we write, it has to be clear and reproducible. You have to be concise, precise. You have to avoid being misleading and confusing. So don't provide confusing information and make sure that none of your information is misleading. Make sure that your message is meaningful. So when you write in statistics, you have to avoid certain things. You cannot say it is interesting to note that. Those are messages that just don't sound pleasant on the ears, and tend to kind of throw people off, so just don't do it. It is interesting to know that, don't do it. The fact that, don't use that either. It should be pointed out that, don't use that phrase either. It is well known that, it is obvious that, I think, I taught you last year to never make statistics personal because it never is about I, and you don't write about I. And you have to make sure you are using no emotions and no emotions involved. Because when you hear people talk like this, when they try and give you numbers and statistics, that should already tell you, oh, maybe I need to walk away from that. That those are your signs of someone's not giving you accurate data, someone's not really, trying to make a point clear, or they don't know how to be effective in their communication. So when you write as well as speak it, because that's what you're gonna have to do, you're gonna have to be able to do all of those things. All right. So when you write, um, so far in Algebra 1, for those who have me, you wrote this in the in Google Slides. In Algebra 2, you wrote 10 pages. You wrote maybe 3 pages, two or none. But I did teach all of you, regardless of what you wrote, about the writing structure in statistics. You have to have an introduction. You have to have a body. You have to talk about the methods. Remember methodology? That's your calculations and that's your decimals, all of that. Your analysis, your results, your conclusions. Reinstate the question, summarize important results, and add recommendations. That's how the right pieces is going to be. But in terms of the conclusion, let me emphasize the conclusion. When you talk about your conclusion, these are the three things that you must include. These are the three things that you have to write, you have to have in your conclusion. Restate the question, summarize the important results, and add the recommendations. Those are the three most important things to make a good statistical conclusion. All right? Now, in statistics, we have to deal with a thing called measurement, which that goes back to our precise definition of mathematics. So refer back to that. Now, statistics deals with numbers. True, planning the productions of data through survey or experiment does not by itself produce numbers. Once we have our participants or our subjects, we must measure the characteristic that interest us. So all this is pretty much just saying, like, if things that interest us, like for me as your teacher, it's going to be your, you know, retainment of the statistics course that I'm teaching you, and you guys are the subject, and I'm looking to see what you know, what you can master in the course. That's pretty much how measurement is. And we're going to talk about the three parts that we have done in class. So before we get into that measurement, let's go ahead and review the statistic types. So you guys, we discussed two things already in terms of the statistics type: descriptive statistics and inferential statistics. So descriptive statistics is techniques to organize and summarize data. So basically just giving talking about the numbers and just keep it going. Like the mean, standard deviation, quartile frequency table, contingency tables. Anything with graphs in particular is a descriptive statistic. Anything to deal with graphs. But let me pause by graph because graphs, depending on which kind of graph you get, you know, that could be descriptive statistics. But also, a graph can also be inferential because you could look at the graphs or whatnot to take care of that. And we're going to talk about inferential statistics. So, inferential statistics, on the other hand, is not about organizing and summarize that because you already done that. It's the technique to interpret meaning of the information. So basically come with the conclusion. So that comes with the correlation, the causation, the hypotheses, the regression, which you guys learned from Algebra 2, and the parameters of the population. And graphs, when we look at graphs, they could help us, make a conclusion. But they're also good for us to talk about, you know, things of increase and decrease. It increased by 4, it decreased by 5, what have you. But the inferential statistics, when we look at the graph, we could say, it increases throughout the summer. It's always it peaks up during the summer if I'm looking at data for temperatures in the summer. The descriptive statistics is going to be, of course, the numbers. Like I said, July is the highest at 105 degrees. But the inferential part, I could always say that throughout the summer, the the weather is the highest during the summer, which is obvious, right? Because it's summertime, it's always going to be hot. That's a basic inferential description. So which type of statistics is this? As homicide increase, ice cream sales increase. This is inferential statistics because we make a conclusion. We are interpreting based on the data we saw. And another good example of looking at graphs, going back to your correlation and regression lesson, when you look in the graph, you can always talk about as something increased, something else increased, like going back to the temperature for outside. The temperature always increased the highest and the fastest during the summer months. That's an inferential statistic. The descriptive statistic be by how much. All right? And this homicide conclusion that we just looked at, that's an inferential statistic. Because that's just looking at conclusion based on a graph they saw. All right, what kind of statistic is this? U.S. history scores decreased by 28%. That is a descriptive statistic. It's a summary, but with a percentage. So the final grades from a biomedical engineering major at University N were analyzed. Results showed that on average, students in this group attained a final grade of 78 in mathematics and an average of 97% in bioethics. That's a descriptive statistic because you're using the percentage, and the percentage falls in the average. What about this statistic? We looked at midterm grades of a sample of mathematics students for University N. For the sample, we were able to estimate that the proportion of the undergraduates who will attain a final grade of 75 or above is between 62 and 79%. Now, you see percentages on this one. I know deep down inside you want to jump to calling that a descriptive statistic. And you will be right if it just solely talk about the percentage. But because you estimate the proportion and you pretty much come to a conclusion, therefore it will be an inferential statistic because you are estimating. It's not set in stone. Descriptive statistics is always set in stone. Always. This example is not set in stone because we estimate the proportion of the undergraduate students. So, estimation. So, here's a table. Talk about the enrolled students and the number of students who pass based on certain majors. What kind of statistic is this? Just to be fair, it can be inferential. I mean, it can be if I made a statement or whatnot saying that everybody takes a math course and most of the people who pass the math course, you know, is whatever. Like if I was to look at biomedical engineering, biomedical engineering has the most students enrolled and the most students who are able to be successful in the course. That would have become an inferential statistic. So this could be an inferential statistic, but just a table by itself, because you see a table and number, it's descriptive because it's just giving you, the specific numbers and all of that. There's no conclusion about it. I mean, it is a conclusion, but there's no statement given. It's just a table with numbers. And you go back to our definition of a descriptive statistic, it taught us about like tables and stuff. So therefore, this is descriptive. And it could be inferential if we make up some conclusions just like we did with the biomedical engineering. All right, so let's summarize what we just learned through those examples. Descriptive statistics describes the features of populations and or samples. It organizes and presents data in a purely factual way. It presents results visually using tables, charts, or graphs. Draw a conclusion based on the known data. Again, when it comes to descriptive statistics, you're given a number like 5%, and you're not using things like could, would, estimation. We're not using that kind of language for descriptive statistics. All right. And we also use measures like central tendencies, the mode, median, distribution, and variance. On the other hand, inferential statistics uses samples to generalize about the larger population. It helps us make estimates and predict future outcomes. It presents research, informs the probabilities, draws conclusions that go beyond the available data. It uses techniques like hypothesis testing, confidence intervals, and regressions and correlation analysis. All right, so now let's move up into statistical parts. All right, in statistics, we always have statistical measurements. We measure everything, How tall I am, you measure me by a yardstick, and you use the units of feet. And guess what? In statistics, we do that. Like, for example, when you buy a TV or whatnot, you know, the inches. and all those things. So we measure property of a person or thing when we assign a number to represent the property. Like here's a final example. My age. So if you was to ask Mr. Howard, how old am I? You talk about me, and the property in this subject is my age. So that's the measure. You measuring my age. And of course, how you gonna measure my age? You have to have an instrument. Often we use instruments to make a measurement. And we have a choice of units we use to record measurements. So, getting back to my age, the instrument could be how long have I lived on this planet? How long have I lived? And you have to find out when I started living, the units of that set instrument. You measuring my age by the number of years. The exact years from when I came into this earth until right now in this very moment. The result of the measurement is a numerical variable. It's the numerical variable that take different values for people, things that different in what we're measuring. So again, going to my age, wherever my age is my variable. 'Cause that's the result of the measurement. And we got those results by the instrument, by measuring how many years have I lived on this earth. All right, so now we're going to take all those examples and we are going to apply them to a topic you know. All you guys have taken me for Algebra 2. Some of you guys have taken me for Algebra 1. So what I want you to do is remember the definitions we just did. Let's apply them to the following example of passing Algebra 2. So in regards to passing Algebra 2, identify the measurement of passing Algebra 2. Where am I measuring your passing Algebra 2? Or the district, I should say. We measure your success in Algebra 2 by your grades. Your grades is your numerical property that belongs to you. That's your grade. That is your property. So therefore it is your measurement. So identify the instrument or instruments of passing algebra. That could be your LEAP, which is everybody, homework, and projects if you had me for Algebra 1. Algebra 2, I did projects as well. Bam. Those are your instruments. Because without the instruments, you don't have the measurement. Identify the unit of passing algebra. That unit the unit that I'm using to measure you passing algebra is about the points that you have earned through the assignments. Identify the variable of passing algebra. Your percentages. So if you guys do not know, and you guys should know this by now, your overall percentage is your variable. That's the number you get in J Campus that determines passing or failing. All right, so this is what I want you to do. Now, this data that you're looking at is all about people who wearing glasses by gender. I was interested about people wearing glasses because I'm thinking about having eye surgery, so I may not be wearing glasses for much longer. All right, but what I want y'all to do is everything that you learn about analyzing data, talking about data, looking at graphs, all this stuff that you have been taught, going back to your ACT skills and neuroscience, and everything before you even met me, period. I want you to describe that. So take a moment, pause the video, and describe everything that you have done, everything about analyzing this data. So pause the video and see what you can do. Alright, I have trust that you have paused the video and you did your analysis. If you have not done so, you need to, describe what you see. Just describe what you see. But if you have done so, let's move on. Now what I want you to do for me, now, is apply what we just done about the measurement, the instrument, and the variables. And you could talk about the units too in regards to this data. So pause the video and discuss that. I trust that you have paused the video. If you have not done so, please pause the video and discuss the statistical measurement stuff we just did in terms of passing algebra. But if you have done so, let's proceed. So let's discuss using the basic data analysis stuff. So we see that we have two graphs, two circle graphs about people wearing glasses. We got one for women, we got one for men. All right. The light blue represent those who wear glasses. The dark blue is those who do not wear glasses. All right. So that's the very basic elementary skill of it. Now let's use descriptive statistics for the data. So using our descriptive statistics, 47% of women wear glasses versus the 53 that do not. Men is 58% who wear glasses and 42% of men who do not. That's the descriptive. Now, let's get on with the inferential statistics. So we're making a conclusion, and that's the inferential statistics. So, again, just looking at this, we can infer that men have poorer vision than women. Women have better vision because it's most men who wear glasses. That's your inferential statistics. So now let's go ahead and set for all those definitions that we just did with the measurement, the instrument, the units, and the variables. So the measurement of this particular study of the is people who wear glasses and not wear glasses. Because we are measuring this study in terms of the gender too. The gender is the category, but the measurement is people who wear glasses and people who don't wear glasses. All right? So that's the measurement. And the instrument in this case, because you don't know if it's a survey or not, it's just looking at people and seeing if they wear glasses or not. Well, the instrument is the number of people who are wearing the glasses and the number of people who not. All right? But you don't have that. So that means that the percentage is going to have to play two parts. The percentages is going to have to serve as the measurement, because you're measuring the percent of people who are wearing glasses or not. And that unit is the percent itself. So in some cases, the measurement and the unit may be one and the same. The variable in this case is the percent itself. So the variable is the percentages. It's that number. All right? So let's go this right quick and fast about our statistical measurements. So the measurement we try is the people who wear glasses or don't wear glasses. That's the measurement. The instrument is the specific number, or in this case, the percentage. And that's the unit, because we measure them by the percentage of people who wear glasses or not. And the outcome of those numbers you see on the graph is the outcome. And the outcome is your numerical variable. All right, things to consider for variables is how exactly the variable is defined. Is the variable a valid way to describe the property it claims to measure? How accurate are the measurements? These are things to consider when you're dealing with variables. And when we're going to get through some data, you're going to have to run through that. So, in class, we talked about the Barrow or level statistics. If you have not done so, go to this website. And in class, sure, for next class, we're going to answer these questions. So, you click on the website. It's in Google Classroom. Matter of fact, I linked the little site for you to go there and answer those three questions. All right, new vocabulary. So we gotta be careful with our variables, because sometimes, the variables may be off sometimes. A variable is a valid measure of a property if it's relevant or appropriate as a representation of that party. All right? Often the rate is more valid measure than simple counted occurrences. So, when you, like, for example, your grades is a good valid measure because it measures exactly how well you do versus the number of assignments that you do, because you guys think, oh, I could pass the class because I turned in all the assignments. That's cool, but when you're looking at the percentage of how much you got correct or mastered. A measurement of a property that has a predictive validity if it can predict success or tests that are related to the property measured. So again, long story short, everything has to be relevant. All right, I'm going too fast. I'm sorry. So here are some examples of valid and invalid measures. So is measuring items with a measuring stick valid? Well, that's valid because it's relevant to what we're doing. We are measuring items, and the measuring stick help us measure items. So that's valid. Does ACT scores measure college readiness? If that's valid. This is not valid because many of you guys can protest that ACT score doesn't really care about college readiness. You could pass tests all day, every day, but it doesn't validate if you're college ready or not. That just means that you could pass a test. All right. So these are examples that I guess I could read this one, but I'm not going to do all of them. Achievement test. When you take a statistics test, you hope that it asks you about the main points of the course syllabus. If it does, the test is a valid measure of how much you know about the course material, which we all could agree to that. Like, for example, if I give you a test, it has to be on stuff that is being taught. Like, I have been talking to you guys about data and analyzing data. So, if I was to ever give you a test, I have to give you a test on that. I cannot give you a test on like the probability of human population or what have you because we haven't done that yet. And so therefore it's not a valid measure of your statistical abilities. All right. The College Board, which administers the SAT, which I talked to you guys about that in person, also offers achievement tests in a variety of disciplines, including AP testing, and they have an AP course for statistics. These achievement tests are not very controversial. Experts can judge the validity by comparing the test questions with the syllabus or the materials they are supposed to cover. So, to help you out, for example, you kids take tests, and this is what we do at our school, and you feel like the test is not valid because you feel like, okay, this was never seen before. We haven't did nothing that look like that. You guys believe in passing tests, meaning that the problems that we practice and review have to look very, very, very similar to what you just done, which that's a false claim that that don't work. If the skills was taught to you, it doesn't matter what the problems look like, you could solve it. All right, I'm not gonna read too much about this. You could pause the video and read and talk about it, but I'm not. Just remember, if an idea is vague, validity becomes a matter of opinion. You're looking for validity. If it's valid, that means that it connects. That means that the idea connects to the measurement of wherever you're trying to get to. Okay, so let's talk about fixing questions because sometimes, you're going to hear people throw questions at you. You're like, well, that's not valid. So let's do it. Is ACT scores a valid measure of college readiness? Which we know this does not. It's not a valid measure. It does not validly measure, someone's college readiness. Do ACT scores help predict student success in college? Now that's true, it does. So the score, predicts like, okay, you're gonna have an easy time or a hard time. If you got a low ACT score, just telling you, colleges is not gonna pay for you. They want you there, but you're not gonna get the money. You're going to rely off the government, and you may have to take out loans. However, it does, it will predict your success. So you got a high ACT score, you know, it's a possibility that you can pass every course without failing it, and we're going to talk about everything. All right. Um, I guess I'll talk about this. A measurement of a property has predictive validity if it can be used to predict success on a test that is related to the property measured. So the ACT stuff we just talked about, that is a predictive valid. I mean, is has some predictive validity to it. Is it always it? Well, we already talked about those questions, so all right. Um, I'm not talking about this at all. You could pause the video, or you could, figure this out, and we could discuss this in class. I may do this in a separate video because I'm pretty much 40 minutes in this video. So you could pause to figure that out. Um, I want you to go through these questions, pause this one, and just answer the question. So I'll read it to you. Count the unemployed. We could measure the extent of unemployment by count or a given rate. The number of people in the labor force grew from 107 million in 1980 to 126 million in 1990 and 140 million in the beginning of 2000. Use these facts to explain why counting of unemployed people is not a valid measure of the extent of unemployment. So, you try that one, pause it, try it. I won't go over that with you. We could discuss it. I want you to try this one because we will do this in class, but I'm not doing it in this video. Something to consider. Statisticians everywhere repeat their measurements and use their average to get reliable results. This is what I want to leave you with because this is critical. You know, when you try to, make a claim about something or a statement, you want to make sure that the data that you use, which is the tools, measures, the topic of interest. Like in statistics, if I was to give you a project, I cannot, it would be invalid to test you on your ability to know the quadratic formula. I'm not using it, it's not taught in statistics, so therefore I can't do that. I want to test you on your ability to apply the statistical concepts as tools, measurement tools, and types of statistics and studies to determine, your statistical abilities. All right, y'all. I want to thank you so much for sticking with me because this video was long, but I'm happy that we was able to get through it.